Okay, we're going to work on interpreting trend lines in our last example, but we're going to practice getting a trend line from our scatter plot, which means we have to draw a scatter plot. So we're kind of going to do the whole thing again. It's good practice, and then we'll be able to extend our thinking on this. The table shows the amount of time required to download a 100 megabyte file for various internet speeds. Assuming the trend continues, how long would it take to download the 100 megabyte file if the internet speed is 75 kilobytes per second? Okay, so first we're going to make a scatter plot of the data and then sketch in a trend line. So these are going to be our x values, the internet speed. So I am just going to write in internet speed. Maybe I'll just write it over here. That's my x values. The y values are going to be the time to download. Just so I remember what the x's and the y's are representing. Okay, so we are going to plot these ordered pairs. I'm noticing that the internet speed is 35, 40, 45, 50, 55, 60. I'm going to count this x-axis by tens. So if we're at 0 here, we'll have 10, 20, 30, 40, and I'm writing in every other 10 just because it's kind of hard to have the space to write in more than that. Well, maybe I can make my graph a little bit bigger. Oh, look at that. Okay, now we're talking. All right, so 60, 70, I'm going to write 80, 90, 100, and I could keep going. Now, the y values are 6.65, 5.82, 5.17. Oh, they're going down. Look at that. 4.65, 4.23, 3.88. So one thing you can do, I think we saw this on a graph in an earlier video, and I probably should have pointed out what it was. I could start counting my graph from 0 and go up, but it might be tricky to get all this to fit. Well, let me see. 1, 2, 3, 4, 5, 6, 7. Oh no, we'll get it to fit. We'll just count by ones. Ignore whatever I was just about to tell you. 1, 2, 3, 4, 5, 6, 7. All right, let's plot our data points. This will be our scatter plot. So our first point is 35, 6.65. You will kind of do some estimating on the location of these. So 35 up 6.65, I think is right about there. Our next ordered pair is 40. So I'm going to go over 40 and up 5.82. It's kind of right below the 6 right there. Now we're at 45 and 5.17. So just be careful. 5.17 is right about 5. Just be careful as you're plotting points that you're remembering how you have numbered your axes so that we're being accurate here. All right, 50, we're up at 4.65, which is just over halfway. 55, we are at 4.23. Right about there. And at 60, we were at 3.88. Okay, well, look at that. We have a negative association because as our y values are decreasing as our x values increase. So from left to right, we are decreasing. And I would say that's a pretty strong linear relationship. So this would have a, just throw some vocab in here, negative correlation. All right, so now we're going to sketch the trend line. So we're going to draw in our trend line as best we can. That's just going to be the straight line going through those points as best as you can. Again, if you have a straight edge, great. I'm just going to draw a line. Oops, mine got a little weird at the end. So there's my trend line. Now to write an equation, we're going to find two exact points on our trend line. So I'm just going to follow along look for some nice clean points on my line that I drew. I'm going to go with that point right there. That ordered pair is 30 for the x and a 7 for the y. I'm going to follow along, follow. Well, let's see. It's not perfect, but I'm going to grab that point down there. That ordered pair is 90 for the x and 0 for the y. All right, so let's write an equation of this line. We start by finding the slope. Slope is y2 minus y1 over x2 minus x1. I'll just do that work up here. Slope is 0 minus 7 over 90 minus 30. 0 minus 7 is negative 7 over 90 minus 30 is 60. And then we can just grab our calculators to see what negative 7 divided by 60 is. All right, that's a negative 0.116 repeating. So negative 0. I'm going to round to the nearest tenth and just say negative 0.1. Now I'm going to take one of the ordered pairs and just plug in the x and the y. So maybe I'll take this first ordered pair. I'm going to plug into y equals mx plus b. The y is 7 equals our m is negative 0.1 times the x is 30 plus, I'm going to make this a capital B so I don't mistake it with a 6. And now we're going to solve for our y-intercept. So first thing is we'll want to multiply the negative 0.1 times 30 and we get a negative 3 plus our y-intercept. Let's go ahead and add 3 to both sides and we get a y-intercept of 7 plus 3, which is 10. So we have our y-intercept, we have our slope. Let's write our equation for our trend line. Y equals negative 0.1x plus 10. Okay, so the question we're asked is, assuming the trend continues. So if we continue, how long would it take to download the 100 megabyte file if the internet speed is 75 kilobytes per second? So they are asking us to figure out how long it would take to download something that is 75 kilobytes. That is an X value. So all that we do is we have a line, a trend line, and so we can use this as a prediction tool. Whoops. We can use our y equals negative 0.1x plus 10, and let's plug in x equals 75 so we can predict how long it will take to download something at that internet speed. So y equals negative 0.1 times 75 plus 10. Negative 0.1 times 75 is negative 7.5 plus 10, and negative 7.5 is a 2.5. So that's, that's a y value of 2.5. The y value was the number of seconds it takes to download something. So we can predict that it will take 2.5 seconds to download a file if the internet speed is 75 kilobytes per second. All right, last question. What is the x-intercept of the trend line? Well, an x-intercept is when you plug in a 0 for the y, so we can take our equation, y equals negative 0.1x plus 10. Let's plug in a 0 for the y. So if you want an x-intercept, keep the x, plug in a 0 for the other value, and let's solve for x. We'll subtract 10 from both sides. So negative 10 equals negative 0.1x. That negative 0.1 is being multiplied by x, so let's divide both sides by a negative 0.1. So x is equal to a positive 100. So what we're saying is that if your y is 0, that's the time it takes to download something. Our internet speed will be 100 kilobytes per second. So is this possible in the real world? So that means a 100 megabyte file that was part of the story problem above would download instantaneously. 0 time has passed and bam, we downloaded our file. A download of any size at all would take at least a fraction of a second. So the fact that we're able to download something in 0 seconds just doesn't happen. You have to have at least a fraction of a second to download something. So I would say that no, this is not possible in the real world situation. So why don't you guys paraphrase and write in a nice little sentence with what we just discussed?